Tsunamis, the ocean's deadliest force. Giant waves with immense power. Massive, unstoppable, deadly. We'll investigate some of the world's most devastating tsunamis, each taking us one step closer to a mega tsunami, a wave that will not just rewrite the record books, it will erase them. No coastline on the planet is safe from tsunamis. They're caused by massive displacements of water, triggered by the Earth's most powerful forces: earthquakes, landslides, and volcanic eruptions. They can travel faster than 500 miles per hour and can stretch for thousands of square miles across the ocean's surface.
It's a good 15, 20 feet tall. Easy.
They strike with huge mass and terrifying speed. The most common way to determine their height is run-up, the wave's highest point of impact on land. Each tsunami will profile has a higher run-up height than the last. Each has its own character, each has its own story, and each brings us closer to the ultimate disaster. The Hawaiian Islands are a tropical paradise attracting millions of tourists. But the islands hold a dark secret. They're blasted by more tsunamis than anywhere else on Earth.
The Hawaiian Islands, sitting as they do in the middle of the Pacific Ocean, are affected by tsunamis from all regions of the Pacific.
The Ring of Fire is a volatile fracture zone surrounding the Pacific Ocean plate. 90% of the world's earthquakes occur here. Earthquakes are the most common cause of tsunamis. That's why Hawaii gets hit often and from all directions. 2:28 a.m., April 1st, 1946. A magnitude 8.1 earthquake rips through the Aleutian Islands off the coast of Alaska. A huge stretch of the ocean floor is lifted, displacing the entire column of water above it. A massive pulse of energy propels a wall of water, a tsunami, at nearly 500 miles per hour towards Hawaii. "2,400 miles away in the small seaside village of Lapahoihoi, children and teachers gather to prepare for the day's classes. Marsu McShane is one of the teachers.
We were in our cottages, and the Akionas who lived in that house that's no longer there knocked on our door and said, "Come see the tidal wave."
At first glance, it's deceptively innocent. What Marsu doesn't know is that tsunamis are not single waves. They move forward in what's known as a tsunami train, a group of waves of many different sizes. First waves are seldom the largest, so what appears to be insignificant is actually the precursor to something much, much bigger. As the tsunami approaches shore, it becomes like a giant train wreck. The front of the wave slows while the back continues to push forward. The energy is compressed, forcing it up and out of the sea.
This got bigger, and so we dropped the camera, ran inside. I can remember the water just crashed in the windows. The roof fell down, and I knew I was going to die.
Marsu spends the next 9 hours clinging to debris before finally being rescued. She is one of the lucky ones. All all of her roommates die, and at the school, 16 children and 5 teachers are lost. But the tsunami is not finished with Hawaii. 23 miles south of Lapahoehoe, the sleepy trading town of Hilo Bay is taken by surprise. Here, the tsunami destroys nearly 500 homes and businesses, killing 96 and injuring hundreds. Walter Dudley is an oceanographer from the University of Hawaii in Hilo Bay. For more than 20 years, he studied tsunamis. One of his most significant findings is that their destructive power is caused not just by the waves, but also by what's underneath them.
Well, one of the things that makes them such an interesting phenomenon to study is that they are all different. And as they travel across the oceans, they're affected by the ocean floor along their tracks. So the waves are constantly being bent or refracted. And then as they come ashore, they are further altered.
No two pieces of coastline are the same. Each has its own unique undersea topography that affects the waves differently. In Hilo, it's the natural rounded shape of the bay.
You can think of a bathtub, and as little children get in a bathtub, they can slosh the water back and forth, and they quickly find out that there's a speed at which the water will really move.
The first 2 waves to hit the bathtub-shaped Hilo Bay cause the water to slosh back and forth. When the 3rd wave arrives, it merges with the sloshing water, creating a larger and more destructive wave. The 3rd wave reaches a run-up height of 30 feet. It destroys most of the foreshore of Hilo Bay. And less than 15 years after the '46 disaster, Hawaii would again be hit by a deadly tsunami. On May 22, 1960, the largest earthquake in recorded history ruptures the Earth's crust off the coast of Chile. 620 miles of the ocean floor is forced up 66 feet, generating a monster tsunami. It's so huge and so powerful that it crosses the entire Pacific Ocean, slamming into Hawaii on the way. This time, technology installed since the 1946 quake warns Hilo Bay residents 5 hours in advance. But the warning falls on deaf ears.
Although the civil defense were saying people to evacuate, there were a lot of us, me included, that out of curiosity went down to look, to see what was going to happen.
Local real estate agent Al Inouye and many others assume that because this wave is coming from the southeast and Hilo faces the north, the bay will be spared. They were wrong. Just after midnight, the first wave strikes.
You could hear people yelling and screaming behind me that were being caught in the wave. That was an experience because, and it still stays in my mind, all this screaming and yelling, and I couldn't do anything about it.
When dawn breaks, 61 people are dead and over 700 buildings are destroyed or severely damaged. The 1960 tsunami takes locals and experts completely by surprise. After thorough study, scientists discover a remarkable aspect of the tsunami. As the wave reaches the shallow water off the southeast coast of the island, the middle of the wave slows, while the outside of the wave keeps moving, causing the wave to wrap around the island. Then, just like in 1946, the natural shape of the bay adds to the tsunami's destructive power. This time, the 3rd wave has a run-up height of 35 feet, 5 feet higher than in 1946. The 1946 and 1960 tsunamis give scientists new insights into the complex behavior and ocean-crossing power of these giant waves. When a local tsunami hits Japan, it strikes with larger and more powerful waves than the 46 and 60 Hawaiian tsunamis combined. And there's no time to evacuate. And a wave that combines sudden impact with awesome size. The ultimate tsunami. When the 1946 and 1960 Hawaiian tsunamis had run up heights of 30 and 35 feet. Shaped and intensified by the ocean floor and coastline, they smashed the islands with unexpected force. But there's another tsunami hotspot where a larger and more deadly wave strikes without warning. After Hawaii, Japan is the most tsunami-prone location in the Pacific. The Japanese have been hit so many times by these giant waves that they created the word tsunami, meaning harbor wave. These waves can come from as far away as Chile or as close as 50 miles offshore. The locally generated tsunamis pose the greatest danger. They strike within minutes of being formed and with awesome power. (10:17 p.m., July 12, 1993). A magnitude 7.8 earthquake rips the ocean floor off the coast of Hokkaido. The epicenter is only 50 miles from the tiny island of Okushiri and generates one of the biggest and most destructive tsunamis Japan has ever experienced. Fisherman Jiro Adachi from the village of Aonai knows about tsunamis. He survived one 10 years earlier that also hit Okushiri. When Jiro feels the earthquake, he knows a tsunami is likely. He quickly evacuates his wife and children from their seaside home, sending them by car to higher ground, while he shuts off the gas. He moves fast, but not fast enough. Just 4 minutes after the quake, the first wave hits him with overwhelming force as it surges to 50 feet.
It started to pull me back into the sea. I managed to hold on to something and thought, I must run to the mountain.
Somehow Jiro manages to find firm ground. He flees to the safety of a nearby hill. Out of the darkness, a second wave strikes. Homes, boats, cars, and trucks spared by the first wave are smashed to pieces. Fires erupt as gas pipes burst. Aonai is a disaster zone. Jiro and other survivors rush to the waterfront to help the injured.
We heard people shouting for help. They were calling, "Help me, help me." I heard a lot of voices, women's voices and children's voices.
Suddenly, amidst the cries for help, Jiro hears something that chills his heart.
Suddenly, I heard a familiar voice between wave breaks, and so I shouted out, "Achan, is that you, Achan?" And then I heard, "Daddy." I heard that from the darkness.
His young daughter is somewhere in the raging sea. As the family fled, the tsunami rolled their car and hurled them into the ocean. Jiro dives into the turbulent waters.
Normally, I'm a great swimmer, but this was incredibly difficult. Sometimes I was swimming, but I couldn't move forward at all. And other times, I'd suddenly be pulled backwards by the sea.
Miraculously, father and daughter make it to shore. 7 hours later, the Coast Guard finds Jiro's wife and son alive, miles out to sea, clinging to debris. As dawn breaks, evidence of the tsunami's power is everywhere. Large parts of Aonai are completely flattened. Fires continue to rage, and most of the fishing fleet is lost. Across the island, 437 houses are destroyed and more than 800 severely damaged. 198 people are dead. The aftermath of the disaster confronts scientists with an intriguing mystery. The two waves that hit Aonai come from completely different directions.
The first wave of the tsunami came from the west area where the seismic center was, and it attacked only the low part in the south of the Aonai area.
But the second wave came from the east, away from the tsunami source.
The second wave came in just 10 minutes after the first, and it attacked all of this area of Aonai.
The first wave that hit the west coast of Okushiri came directly from the source. But then, just like in Hawaii, the tsunami wrapped 180 degrees around the island, creating a second wave that struck Aonai from the opposite direction. But the wraparound effect does not explain why the tsunami hit Okushiri with such brutal force. The culprit was the proximity of the earthquake. After a tsunami is generated, it spreads out like a ripple on a pond. As the ripples expand wider and wider, the energy spreads out over a larger area. The closer the source of the tsunami is to the impact zone, the more concentrated the energy. Okushiri was only 50 miles from the source, so it received the brunt of the tsunami. Just north of Aonai, the waves reached a staggering 101 feet. Today, the legacy of the 1993 tsunami is set in concrete. Huge walls up to 36 feet high and extending 22 miles along the coast stand guard against the sea. Powerful steel gates protect river mouths, and the harbor is bolstered by concrete blocks to reduce wave impact. These ramparts against the waves are stronger than normal seawalls. The forces they must withstand are much more powerful than normal waves. Normal waves form through the transfer of energy from the wind to the ocean surface. Tsunamis are generated by intense transfers of energy. Even the largest wind waves have a maximum wavelength from crest to crest of a few hundred yards. Tsunamis can have wavelengths of hundreds of miles. When they hit, they keep coming and coming. The Okushiri event shows how destructive a local tsunami can be. It strikes with undiluted power and speed, leaving little time for escape. But that disaster is eclipsed by a far bigger tsunami, a wave generated by an earthquake so powerful it moves the entire planet. A wave that takes us one step closer to the ultimate tsunami. When we return, the tsunami that hit Okushiri, Japan came from just 50 miles away and reached a run-up height of 101 feet. It killed 198 people and destroyed most of the fishing village of Aonai. But it pales in comparison to the deadliest tsunami of modern times. (7:58 a.m., December 26, 2004). Deep in the ocean off the coast of Sumatra, Indonesia, 750 miles of the Earth's crust ruptures in the second largest earthquake ever measured. The 9.3 quake shatters buildings and destroys lives. But it is just a precursor to an even more horrific disaster. An epic tsunami spreads across the entire Indian Ocean, striking 12 countries. As with Okushiri, Japan, the local effects are the most immediate and the most devastating. 16 minutes after the quake and 155 miles from its epicenter, northern Sumatra is struck by 115-foot-high waves. The capital city of Banda Aceh is decimated. More than 160,000 people are killed. Coastal engineer Dr. Jose Barrero arrives in Banda Aceh 4 days later.
I've seen hurricane damage, and I've seen some flood damage before, and I've seen a lot of tsunami after effects before also, but this definitely was the worst. What was amazing about it was the scale.
70% of the buildings in Banda Aceh are flattened. More than 43 miles of coastline show evidence of wave heights over 100 feet.
It was a level of destruction that was, over hundreds of miles of the coastline, the same level of destruction. So it wasn't just isolated pockets of areas that were wiped out, but the entire coast and then the entire city of Banda Aceh.
An hour and a half after Banda Aceh is leveled, the tsunami strikes Thailand. A wall of water swamps beachside villas, hotels, and villages.
That wave is a good 15, 20 feet tall. Easy.
More than 8,000 people die. "1,250 miles to the west, on the island nation of Sri Lanka, 100 billion tons of water surge inland, killing 35,000 people and leaving another 500,000 homeless. In all, nearly 230,000 people die in the most devastating tsunami in recorded history. The death toll is higher than for all other major tsunamis in the past 300 years combined. The power of the earthquake that triggered the tsunami was staggering. The entire planet's sea level rose by 4/1000ths of an inch. Every spot on Earth moved at least half an inch. As scientists struggled to comprehend the enormity of the event, a bizarre anomaly came to light, one that made the tsunami even more deadly. The morning of December 26th is quietly dawning on the peaceful shores of Galle, Sri Lanka. British tourists Camilla and Dominic Welby are sleeping in their beachside bungalow with their 11-year-old son Hector. Suddenly, Dominic is awakened by a strange noise.
I went outside onto the veranda and I noticed that the water, which should have been at low tide, was up against the wall of the garden.
What Dominic is seeing without realizing it is the first sign of the tsunami. At the point of its creation, the bottom of the tsunami, called the negative wave, went east towards Thailand and Indonesia, while the top, called the positive wave, went west towards Sri Lanka. When the bottom of a wave arrives first, gravity sucks the water out, dramatically lowering the sea level. When the top of a wave arrives first, it comes like a flood. This is what the Welbys are experiencing.
I didn't know what it was. And at that moment, the floor exploded.
The tsunami rushes in, destroying the bungalow.
The force of the water was phenomenal. To be exploded out of your bed, to feel a piece of furniture just be thrown up into the air and to be thrown off it and to have to jump, it's just very weird. And to then be sucked out and tossed around like being in a washing machine.
The couple grab their son and scramble into the bathroom.
With with each wave, with the intensity of each wave, because it would fill up the shower cubicle completely. We would be swirling around underwater, trying to, regain our purchase on whatever we could find.
But as the waves continue to pound, the concrete walls of the bathroom begin to crumble. Hector is trapped under a large piece of concrete, struggling to keep his head above water.
The idea of your child dying before you it's nothing worse.
A third wave surges over Hector's head. He is seconds from death. But instead of drowning him, miraculously, it lifts the concrete slab off his foot and releases him. The wave that's caused so much death in this one instance is life-saving. But it's the peculiar behavior of tsunami waves that makes them so deadly. Surging forward and then pulling back, billions of tons of swift-moving water carry a dangerous mass of deadly projectiles, broken timber, glass, metal, and vehicles. The third wave turned Galle into one of the hardest-hit areas in the nation. As the people of Sri Lanka struggle to recover, tsunami scientists like Dr. James Goff arrive in the devastated nation.
One of the really difficult things when you go into these areas is you are going there because you have a mission to learn about the tsunami from a scientific point of view. It's very important to learn these things, and yet there is the human tragedy going on around you, and it's very difficult to isolate yourself from that human tragedy.
Amid the horror, Goff and his colleagues discover the oddity of the third wave.
So there's Galle quietly sitting there, recovering from being hit by two waves, and then bang.
How and why the Galle area was hit by this third wave intrigued experts. Where did it come from? The first clue in the mystery was uncovered by looking at a global map. Sri Lanka is directly in the line of fire of the tsunami.
Sri Lanka was basically staring down the barrel of a loaded gun in a way.
The second clue came only after careful analysis of the tsunami's unique behavior.
So the tsunami wave goes all the way past Sri Lanka, heading off to the east coast of Africa. But on the way, whack, it hits into the Maldives, and a lot of the energy is reflected back from the Maldives, and the first place that hits is Galle.
The tsunami was so powerful, its reflected energy carried a third wave, 500 miles back across the Indian Ocean. In total, over 4,000 people died in the Galle region. The tragedy confirmed scientists' theories about the phenomenal reflective power of tsunamis. The Indian Ocean tsunami continues to offer scientists complex and compelling new data, much of which is still being processed.
It's really difficult to say right now what the Boxing Day tsunami taught us compared to what we didn't know before, because it's taught us so much. It taught us that we actually don't know a lot and that we have a lot more to learn.
What the Welbys learned is that life is fleeting and precious. In appreciation for their survival and in recognition of the thousands that did not survive, they spearheaded a fundraising effort back home in England. To date, they've raised $25,000 for the people of Galle. Many mysteries about the Indian Ocean tsunami remain unanswered. One of the biggest questions is how the highest waves could have reached a staggering run-up height of 115 feet, far beyond what had been considered physically possible by an earthquake-triggered tsunami. As huge as that tsunami was, it's not the biggest wave to strike in recent history. Landslides have triggered a different kind of killer tsunami. And scientists believe a mega tsunami looms in our future. A wave of such epic proportions that nothing like it has been seen since prehistoric times. When the 2004 Indian Ocean tsunami unleashed a series of enormous and deadly waves that had run-up heights of 115 feet. but they are dwarfed by another wave that forced scientists to become detectives. What they discovered was a new kind of tsunami, one of unimaginable size and power. In a remote bay in southwest Alaska, a native legend tells of a beast that shakes the ocean and destroys those that walk its shores. In 1958, a local fisherman came face to face with that beast, a wave more than twice the height of the Golden Gate Bridge. The story of this incredible phenomenon begins 5 years earlier, with 2 American geologists on assignment in Lituya Bay, Alaska.
We were in the bay mapping the geology and primarily interested in the stratigraphy because of the oil potential of that part of the Gulf of Alaska.
They didn't find any oil, but they did find one of the biggest scientific mysteries of the century. Dr. George Plafker was one of the scientists.
One of the obvious things you see when you're in that bay, if you're looking closely, is that the trees are of different ages as you go away from the shoreline.
Plafker and his colleague noticed that a band of younger trees circled the entire bay, hundreds of feet above the water. The scientists knew this dramatic change in vegetation meant a large-scale disaster had struck the area, but they saw no evidence of fire or avalanches.
So we speculated about what that could be and had all kinds of ideas about glaciers shoving forward very rapidly. The other was that there were submarine slides going on at some of the deltas along the margin of the bay, or that there was breakouts of large amounts of water up higher along the glaciers and then they flood down all of a sudden. We had everything except the right way the right idea about how those waves could form.
The geologists left Lituya Bay without solving the mystery. 5 years later, they got their answer. In 1958, Howard Ulrich takes his 8-year-old son, Howard Jr., on a fishing trip to Lituya Bay.
So we went into our favorite anchoring spot and dropped our anchor and made supper, and finally about 9 o'clock we went to our bunks.
An hour later, the boat starts shaking violently. An 8.3 earthquake centered 13 miles from Lituya Bay rips across the water. Howard and his son rush up on deck just in time to see the most amazing sight of their lives.
It looked like a big explosion, like you've seen big explosions in the water on TV. That's exactly what it looked like.
What happens next defies imagination.
As the spray started to settle down, out of the bottom of it came this huge wave. I would say that the wave was close to 1,000 feet high at that time, the actual wave.
Traveling at an estimated 70 miles per hour, the liquid mountain is charging straight for Ulrich and his son.
Just coal black and full of logs, just straight up and down. It was actually a pretty horrifying looking sight. Just thought, you know, this is the end. There's no way you're going to get out of this, you know.
In a desperate attempt to keep control of his boat, Howard turns on his engine and drives directly into the wave.
Started pulling all the anchor chain out, and when it got to the end of the chain, I thought it was going to pull the bow of the boat under, but it snapped that chain just like it wasn't even there.
The giant wave lifts the tiny boat high into the air.
I looked out over the stern of the boat, and we were looking down on the trees. I figured that's where we were going to end up.
Unbelievably, their boat rides up and over the wave, and the Ulrichs land back in the bay unharmed. 2 other vessels and their 4 occupants are not so lucky. This incredible footage is filmed the next day. Everything in the wave's path is destroyed. No trees are left standing, and most soil is ripped off right down to the bedrock.
Run-up height of 1,740 feet is the world record, I think, for anything that's happened in historic time. And it was, it's 500 feet higher than the Empire State Building. That's pretty big.
The earthquake felt by Ulrich triggered a massive rock slide, sending 40 million cubic yards of mountain hurtling into Lituya Bay. The debris slammed into the water, creating the giant wave.
It just swooped down a very steep slope and ran out into the fjord and basically forced all the water out of that little arm in front of the glacier and shot it up over the ridge that was on the other side.
One mystery remained. The amount of water displaced exceeded the amount of land that fell into the bay. It took 42 years to solve this mystery. Scientific models determined that the rapidly moving landslide created an air pocket behind the wave, preventing the water from sloshing back. The force of the air pocket combined with the size and weight of the landslide shot the water out of the bay like a huge missile.
It would be the same as if you took a paddle and ran it down, pushed into the water full speed at a high velocity, just push all the water right out.
The effects of the giant Lituya Bay wave remain clearly visible today. The event rewrote the history books and changed our understanding of tsunamis forever. Landslides can and do produce waves far larger and more destructive than ever thought possible. Lituya Bay's desolate location limited the damage caused by the giant tsunami. But should an even bigger landslide-generated wave strike a major city, the result will be the ultimate tsunami. In 1958, a landslide-generated tsunami taller than the Empire State Building obliterated an Alaskan inlet. It was an overwhelming display of nature's power. But across the Pacific Ocean, on the gentle slopes of Oahu, Hawaii, scientists have uncovered evidence of a potential disaster that could dwarf the Indian Ocean and Lituya Bay tsunamis combined.
It's almost incomprehensible, the scale, the enormity of these things. It would be quite a view.
Gerard Fryer is a geophysicist from the University of Hawaii. He uses advanced computer modeling and field data to forecast tsunamis. His research has uncovered a potential wave so big that even the best-laid evacuation plans may not be enough.
These things have been described as culture-ending events. The state would essentially be knocked back to the Stone Age.
This mega tsunami would combine the dizzying height of a landslide-triggered wave with a tsunami that strikes a densely populated landmass, in this case, Hawaii. On the island of Oahu, locals and tourists alike flock to the sea, basking in the perfect climate on one of the most famous coastlines on the planet. But in our scenario, everyone is oblivious to the fact that less than 300 miles to the east, a disaster of biblical proportions is about to strike. The ultimate disaster is triggered by the eruption of the world's largest volcano, Mauna Loa, on the Big Island of Hawaii.
In the case of Mauna Loa, and that's the 800-pound gorilla here, that's the big volcano that we have to worry about. As Mauna Loa is preparing for eruption, the southwest rift zone of Mauna Loa inflates with magma. The entire mountain swells, which means that the outer slopes get steeper. There are probably a succession of small earthquakes, and then maybe a big earthquake that shakes loose this very steep western flank of the volcano.
Almost 360 cubic miles of earth and rock plummet into the sea. On impact, the land displaces a massive amount of water. The ocean rushes back to fill the giant gap. From this cataclysmic disturbance emerges the tsunami, heading directly for Honolulu. Estimated time to impact, 30 minutes.
This is the direction that a big tsunami would come from the Big Island.
The wave first becomes visible as it stands and breaks on a shallow bank 25 miles southeast of Honolulu.
You'd see the sea rear up in front of you. It would be huge. It would rise up above you the size of a building, the size of a 10-story building.
Surging inland at up to 43 miles per hour, the tsunami slams into the city. Because the tsunami's energy stretches down to the ocean floor, this wave is not clean water. It's filled with sand, coral, and rock. Water penetrates 10 miles inland before being sucked back out to sea in a lethal whirlpool of wreckage. It annihilates everyone and everything in its path.
These giant landslides, as far as we can tell, they seem to occur during periods of high sea level when the climate is warm. Quite why that is, we don't know. But we are in a warm period right now with high sea level. So we should expect something like this within the next 10 or 20,000 years.
As the unofficial tsunami capital of the Pacific, Hawaii is preparing for the future. Scientists continue to develop a global network of warning systems based on real-time seismic analysis and deep-sea wave sensors. Alarms will sound as soon as 90 seconds after the initiation of even a small tsunami. Tsunamis are global events with global ramifications. They combine the almost unlimited power of the Earth with the gargantuan might of the sea. They are a constant reminder of the awesome strength of nature. While scientists learn more about tsunamis and engineers build stronger coastal barriers and experts implement improved warning systems, individual vigilance remains essential.
And you see the water withdrawing, strangely, curiosity shouldn't compel you to go down and see what's going to happen next. The alarm bell should be going off.
It's something that we need to have embedded in our culture, in our knowledge base, and in our education so that we know what to do when the next tsunami happens. Not if, it's when. It's something we need to learn to live with.
As long as the phenomena that create these great waves continue, we will have tsunamis. And it's always just a matter of time before the next one strikes.